So I just stumbled upon this new Python library called semlib, and it's fascinating how it combines functional programming with LLMs.
Wait, really? I mean, that sounds cool. How does it actually use those programming concepts?
Well, semlib offers building blocks like map, reduce, and filter, but you describe them using natural language instead of code.
That's such a clever approach. So it streamlines how we interact with data using LLMs, right?
Exactly, it seems like it simplifies complex tasks by breaking them down into smaller, manageable steps.
But hold on, doesn't that assume users already know how to break down their tasks?
Good point, it might be a bit intimidating for beginners who aren't familiar with functional programming.
And what about the performance? I mean, does using smaller models actually yield better results?
Yes, the idea is that by using simpler models on smaller tasks, you can enhance both quality and latency.
That's super interesting. So you can even run parts of the computation concurrently.
Absolutely, this means it can handle tasks like analyzing large datasets much more efficiently.
Now I'm curious about real-world applications. Any examples of how it's used?
For instance, it can sort archive papers or analyze support tickets, tasks that typically involve tons of data.
Those are great examples, but what do you think about the security aspect?
Oh right, by breaking tasks into smaller ones, you can use self-hosted models for sensitive data.
That's a solid feature, but do you think it's reliable enough for critical applications?
I'm not entirely convinced, it might depend on how well the models are trained.
That's true. What about flexibility? I read semlib lets you mix LLMs with standard Python code.
Yes, this way you get the best of both worlds, using LLMs for natural language tasks and Python for computations.
It's like having your cake and eating it too. But is there a steep learning curve then?
Probably, but for those who dive in, it could lead to some pretty exciting discoveries.
Now I'm wondering about the cost implications. Does it really save money?
Yeah, smaller models mean potentially lower processing costs, especially if you can choose the model for each task.
It's intriguing how economic factors intersect with technology. Any downsides to this model?
Definitely, if users misuse the functional primitives, they might get poor outcomes from their data analysis.
That's a fair warning. It makes me think about the responsibility of users in general.
Right, if users don't understand the tools, they could misinterpret results, leading to flawed decisions.
Totally. So there's this balance between accessibility and complexity.
Exactly, and that makes it necessary for educational resources to grow alongside tools like semlib.
Interesting. Speaking of resources, what about the community around semlib?
Good question, the more open-source nature could foster collaboration and improvement.
That could make a big difference. It's like a collective brainpower scenario.
For sure, just imagine how quickly innovations could happen in such a community.
That reminds me. What's the citation for semlib if anyone wants to reference it?
You'd cite it as a project by anishathalye, which gives credit and adds to academic discussions on LLMs.
Great. So, in closing, would you say semlib changes the game for data processing?
Definitely a game changer, but it emphasizes the importance of user understanding.
Right. So, it'll be exciting to see how it evolves and how people adapt.
Absolutely, I wonder what the next developments will be. It's a journey for sure.
For sure. And it leaves us with the question, how much can we really trust LLMs in complex tasks?
Exactly, it's a balancing act between potential and caution in this tech-driven world.